Hi everyone, Assalamualaikum. In this video, we are going to discuss example 2 from the previous semester papers under chain rule. If z equals to ln x plus y, x equals to t plus cos t and y equals to tangent t over 4, use chain rule and partial differentiation to find the value of dz over dt when t equals to pi. Right, first step, to find dz dt, we need to find del z over del x and del z over del y. Okay, because z is related with variable x and y, right? And after that, we can write in terms of t. Okay, so to find del z over del x, we differentiate from z. Z equals to ln x plus y. Okay. Del z over del x means partial derivative of z with respect to x. We treat x as a variable and we treat y as a constant. Right? Then we can find del z over del x equals to 1 over, when we differentiate ln x plus y, it is equals to 1 over x plus y times 1 plus 0. Okay, how we get this? Okay, to differentiate ln x plus y, x means variable, y means constant. So we just imagine, let's say we want to differentiate ln variable x plus constant 2 with respect to x. Okay, then we have 1 over the function inside ln, which is x plus 2. Then we differentiate the function in ln. We differentiate x equals to 1 and then plus, we differentiate constant 2 equals to 0. So that's why we get this. Alright. Okay, so del z over del x equals to 1 over x plus y times 1 plus 0, right? After that, we simplify, so we get 1 over x plus y, okay? Then we can write del z over del x in terms of t, okay? So we have 1 over, we replace x equals to t plus cos t, so we get this, okay? And we replace y equals to tangent t over 4. So we get this. Okay. And then after that, we can find del z over del x at t equals to pi. Okay. So del z over del x when t equals to pi equals to 1 over, we replace t equals to pi. So we get pi and then cos pi plus tangent pi over 4. Okay, so we get pi plus cos pi equals to negative 1. So we get pi plus negative 1, which is pi minus 1. And then plus tangent pi over 4 equals to 1. So we get plus 1 here. Then after we simplify, so we get 1 over pi. Okay, now we done find del z over del x when t equals to pi. Okay, so after that, we need to find del z over del y. Okay, we can find del z over del y from z. Okay, from z equals to ln x plus y. Okay, del z over del y means partial derivative of z with respect to y. We treat y as a variable and at the same time we treat x as a constant. So to avoid error and easy to differentiate, we can write variable x in different colors. Okay. Alright, so to differentiate ln x plus y, we can imagine, let's say we want to differentiate ln and then x here is constant. So let's say we replace by 3. Okay, we assume equals to 3. And then plus y and then we differentiate with respect to y. So we have 1 over 3 plus y. Then we differentiate the function inside ln. We differentiate constant 3 equals to 0. And then plus we differentiate y with respect to y equals to 1. Then we get this. Okay, 1 over our x equals to 3. Okay, we assume equals to 3 and then plus y and then times 0 plus 1. Okay. After that, we simplify. So we get del z over del y equals to 1 over x plus y. Right? Then we can write del z over del y in terms of t. Okay. So we replace x equals to t plus cos t and we replace y equals to tangent t over 4. Okay. Then we can find del z over del y when t equals to pi. So we just replace t equals to pi. So we get 1 over pi plus cos pi plus tangent pi over 4. So equals to 1 over pi, cos pi equals to -1 and the plus tangent pi over 4 equals to 1. Then we simplify, so we get 1 over 3. Okay, this is the value for del z over del y when t equals to pi. Okay. From the previous slide, we get del z over del x equals to 1 over pi and del z over del y equals to 1 over pi. Then we can continue with step 2. Find dx over dt and dy over dt. To find dx over dt, we differentiate from x and x equals to t plus cos t. Then we can find dx dt. We differentiate t equals to 1 and we differentiate cos t equals to negative sin t. And from here, we use normal d or straight d because we only have one variable t here. Okay, no need to use del symbol. Okay, and then when t equals to pi, so we can find the value of dx over dt. We replace pi into t here, so we get dx over dt equals to 1 minus sin pi. And sin pi equals to 0, so we get 1 minus 0 equals to 1. Okay, 1 here means the value of dx over dt when t equals to pi. Okay. After that, we need to find dy over dt. Okay, we can find dy over dt by differentiate y, okay, with respect to t. So from y equals to tangent t over 4, or we can write tangent 1 over 4t. Okay, so when we differentiate tangent 1 over 4t, so we get dy over dt equals to sec squared 1 over 4t or t over 4 and then time 1 over 4. Okay. Alright, to differentiate tangent 1 over 4t, we just imagine, let's say we want to differentiate tangent, let's say 1 over 4 here is 2. Okay, 2t with respect to t. So when we differentiate, we get sec squared 2t. Then we differentiate 2t with respect to t. So we get 2 here. Okay, so same goes to tangent 1 over 4t. When we differentiate, we have sec squared 1 over 4t or t over 4 and then times 1 over 4. Okay, then we cannot multiply 1 over 4 and t over 4 here. Okay, because t over 4 here means composite function with sec squared. Okay, so from here, we can move 1 over 4 to the front. Okay, so we get 1 over 4 sec squared t over 4. Okay, then we can find the value of dy over dt at t equals to pi. Okay, so we substitute pi into variable t. So we get 1 over 4 sec squared and then pi over 4. Okay, then to find the value of sec squared pi over 4, we can use reciprocal function where sec pi over 4 means 1 over cos pi over 4. Okay. Alright, so from here, cos pi over 4, okay, equals to cos 45 degrees. So from this diagram, cos 45 equals to adjacent over hypotenuse. So we get 1 over sec 2 here. Then we have squared here. Okay. After that, we get 1 over 4 and then bracket squared. So we get 1 over 2. Okay, no more sec here. Then we can simplify 4 and 2. So we get 2 here. So means dy over dt at t equals to pi equals to half after we simplify. Right? Now we done find dx over dt and dy over dt when t equals to pi. Okay, so the next step, step 3, we set up the chain rule formula. Okay, now we want to find dz over dt. Okay, so to set up the formula, the first numerator should be del z. Okay, and since we have two variables for z, variable x and y, so we have two pairs of multiplication of derivative. Okay, and in between must plus sign here. Okay, then we just imagine, let's say we can simplify dz and del z here, dx and del x here, and we just imagine, let's say we can simplify dy and del y here. Okay, so when we simplify, we just imagine. Okay, then we get back del z over del over dt here. Okay, so we get dz over dt from the left here. Okay, then dz over dt equals to, we replace del z over del x equals to pi over 4. And then times dx over dt from here equals to 1. So we replace here. And then plus del z over del y from here 1 over pi. And then times dy over dt from here. Okay, 1 over 2. Then we simplify or we factorize. So we have 1 over pi and then in bracket 1 plus half. Okay, means 1 over pi times 3 over 2. So when we simplify, it equals to 3 over 2 pi. So 3 over 2 pi is our dz over dt when t equals to pi. Right? Coming up next, more examples for chain rule. If you like this video, you can subscribe. Thank you for watching. Stay tuned. Bye. Assalamualaikum.